Hello students, hope you must have gone through the first two videos. In the first two videos we have discussed about the concept of work, power and energy along with their SI units, and you have been asked to solve all the numericals. And if you have any type of problem or doubt in any of the numerical, you just let me know. And I will definitely help you out. Now in today's video I'm just going to start with the topic that is different forms of energy. Page number is 29. So today's topic is different forms of energy. First of all, we will start with the mechanical energy. Mechanical energy is the sum of its potential energy plus kinetic energy. Now, first of all, we shall start with the potential energy, and it is represented with the letter capital U. Now, what is the potential energy? The energy possessed by the body at rest due to its position or size and shape is called potential energy. So once again, the energy possessed by a body at rest due to its position or size and shape is called the potential energy. Like this pen is lying on this book. Now the energy possessed by this pen due to its shape and size, since it is in rest, so it possesses potential energy. Now the next is potential energies of two types. Potential energy is of two types. One is gravitational potential energy. Gravitational potential energy. Now, simply you can define it: the energy possessed by the body due to its height. The energy possessed by the body due to its height, that is known as gravitational potential energy, and it is represented as mgh. M is the mass and g is the acceleration due to gravity and h is the height. So this is the gravitational potential energy. Now the next is elastic potential energy. Elastic potential energy. Now the potential energy possessed by a body in the deformed state to change in its size and shape is called the elastic potential energy. Like suppose you can take a case of spring. When it is stressed, its shape is deformed, and after some time it regains its original configuration, and this is all due to the property of elasticity. And if again the spring is compressed and after some time again it regains its original configuration, that is all due to the property of elasticity. So we can state that the potential energy possessed by the body in the deformed state due to change in its shape and size is called the elastic potential energy. Now let us move to the next, that is the kinetic energy. Kinetic energy. Now You must be knowing the definition of kinetic energy. The energy possessed by a body due to its state of motion is called the kinetic energy. Once again, the energy possessed by the body due to its motion is known as kinetic energy, and it is represented with letter K, and this is mathematically this is equal to 1 by 2 mv square. M is the mass of the body and v is the velocity with which the body moves. Now the next topic is expression for the kinetic energy. Expression for the kinetic energy, that is 1 by 2 mv square. Now this is the topic. Now let a body of mass take m is moving with a velocity v, and it is brought to rest by applying a constant opposing force that is equal to F, and let A be the uniform retardation, and let retardation is A. It is just like this. This is a body and it is moving on the plane surface in this direction, and now the opposing force is applied in the opposite direction of it, and its retardation is A, and when the opposing force is applied, the body travels a distance S. Now you can apply Newton's second law of motion here. According to Newton's second law of motion, F is equal to ma. A is the retarding force. Now just see that in this case work is done against the kinetic energy of the body. It means that the kinetic energy of the body is equal to the work done. Can I write here? Kinetic energy is equal to work done, and as we know that work done is equal to force into displacement. Now from equation 1 you can put the value of F here, ma into S, and let this is equation number 2. Now we have to calculate the displacement. To calculate the displacement, create the displacement S, we have initial velocity, that is u, and it is taken as v, and then the final velocity, that is v, and it is 0. And now from the equation of the motion, that is v square is equal to u square plus 2as. Now In this case V is 0 and U is equal to V square, and this is equal to minus 2AS, since A is a retardation. That is why A is taken here negative. I am just going to write here A is a retardation. So from here we can find out V square, that is equal to minus 2AS, minus minus cancelled, and S is equal to V square upon 2A. Let this is 3. Now by putting the value of S, by putting the value of S from equation 3 in equation 2, that is this equation MAS. So K is equal to MA into S, that is V square upon 2A. A and A get cancelled, and this is equal to 1 by 2 MV square, and this is the required result. So this is an expression for the kinetic energy. Now let us move to the next topic, and this is one of the most important relation, that is the relation between kinetic energy and momentum. This is the topic, relation between the kinetic energy and momentum. Now, as we know that kinetic energy, that is equal to 1 by 2 mv square. Let this is equation number 1. And as we know that the linear momentum is the product of mass into velocity. Now let this equation number 2. Now from here we can take V is equal to P upon M, and now we can substitute the value of V in equation 1 by putting the value of V in equation 1, we get it is K is equal to 1 by 2 M P upon M square. So this is equal to 1 by 2 M P square upon M square. This and this cancelled, and we get P square upon 2M. This is the relation between the kinetic energy and the momentum. Now this relation represents that kinetic energy is inversely proportional to the mass. It means that if the body is having less mass, its kinetic energy will be more, and if the mass of the body is more, and its kinetic energy will be less. Now we can find the value of P also here. So P square is equal to K into 2M, and P is equal to under root K to m. Now these two relations will help you to solve the numerical problem and even some logical type questions. So just don't forget, whenever there is a numericals related with the momentum and kinetic energy, straight way apply this relation and you will be able to find the required quantity, whatever it is. So just go through it. K is equal to p square upon 2m and p is equal to under root k to m. Now move to the next topic. Now the next topic is work energy theorem. Next topic is work energy theorem. Now in order to understand this, this is an body and it is moving in this direction. Now the force is applied on this body in the direction of its motion. Now what will happen? The kinetic energy of this body will increase, and this is what work energy theorem is. So we can state that the work done by the force on a moving body in the same direction is equal to the increase in its kinetic energy. This is what work energy theorem is. So let us prove it. The proof of this is, again, let a body of mass m moving with initial velocity, that is u, and when a constant force F is applied on it, the constant force F is applied on it along the direction of motion, it produced an acceleration A. It produced acceleration A, and now the velocity of the body changes from u to v, and let its final velocity is v, and it moves a distance s. Now students, increase in velocity, just note on this point, increase in velocity means final velocity minus initial velocity, or you can write it v minus u. Now according to Newton's second law of motion, F is equal to ma, and the work done by the force, that is equal to force into displacement. Now from equation 1, F is equal to ma into s. Now again from equation of motion, that is v square is equal to u square plus 2as. Now here we can find s is equal to v square minus u square upon 2a, and let this is 2, and let this is equation 3. This equation is 3. Now by substituting the value of S in equation 3, we get W is equal to, in equation 2, it is equal to MA into S, that is V square minus U square upon 2A. So A and A get cancelled, and this is equal to 1 by 2 B square minus U square, or even you can write it 1 by 2 MB square minus 1 by 2 MU square. So we can write work done is equal to final kinetic energy minus initial kinetic energy, and this is what work energy theorem is. Now students, there are so many conversion of potential energy and kinetic energy is given. So now you are supposed to go through it. I'm just opening the book. Just see to it, forms of kinetic energy. There are two types of kinetic energy, that is translation kinetic energy, rotational kinetic energy, vibrational kinetic energy. Just go through it, and then this is important, that is conversion of potential energy into kinetic energy. Just go through all these examples which are given, and these are all important, which can be asked to you in the exams. Now here it is given, like conversion of energy, dynamo. In dynamo, mechanical energy is converted into electrical energy, and in motor, the electrical energy is converted into mechanical energy. So like this, you can go through all these examples of energy conversion, and these are all important. And if you come across any type of the problem, you just let me know. So with this, your this topic is finished. So many numericals are given at page number 41, and 42. Means total 23 numericals are there. So you need to solve it, and these are all important numericals, and hope you will try it at home. So that's all for today. Thank you very much.